we had a probability distribution. We looked at our bag of M&Ms, and we could get the color of the probability of getting a red or the probability of getting a blue. But if I gave you that same bag and then said, what's the probability of getting an orange, red, or yellow when I draw it out? So then that changes things because I have multiple options that would be acceptable. And so we have to figure out how to count that. We do have a definition that will be very important. We'll talk about a lot. You'll hear me mention like disjoint or mutually exclusive. And that means they have no common outcomes. They cannot both happen. When I'm talking about my M&Ms, is it possible that I draw an M&M out of the bag and that M&M is both red and green? No, it's one or the other. So red and green are mutually exclusive events. They cannot both happen at the same time. So if your events are disjoint, so there's no overlap, we have two things and they cannot both happen, then the probability of E or F happening is probability of E plus probability of F. If I want the probability of getting a red or yellow M&M, okay, I can't get both at once, so all I have to do is add the probability of a red plus the probability of a yellow.
What's your question?
I'm going to give you a probability distribution. It shows the number of rooms in a housing unit in the United States. Okay, so we can have these rooms, and can we agree that the number of rooms would be mutually exclusive? You can't have a housing unit that has both a total of 3 rooms and a total of 7 rooms. It's either 3 rooms or it's 7 rooms. There's no in between. So if I want to verify that it's a probability model, what do you have to do? 2 requirements. They have to add up to 1, and each individual probability has to be, look back in your notes from yesterday, there are 2 requirements. Think about what your probabilities have to fall between. Yeah, every probability has to be between 0 and 1. So we can check that, and that's true. And add them up. Do we get 1 when we add them up? And I think they do. So the sum is 1 and each individual thing is between 0 and 1. So that's what makes it a probability model. B, if I want the probability that a randomly selected housing unit has 2 or 3 rooms. So I'm going to start writing things out using our probability notation just to get used to it. Probability of 2 or 3, since they're mutually exclusive, that's just the probability of 2 plus the probability of 3. So the probability of 2 rooms is 0.032 plus probability of 3 rooms is 0.093. So we get 0.125. So there's a 12.5% chance that you would have either 2 or 3 rooms in your unit. Alright. What's the probability that a randomly selected housing unit has 1 or 2 or 3? So the addition rule in our formula sheet only shows you adding 2 things, But you can do as many as you want, as long as they're mutually exclusive. So we just have to add all three probabilities. And we get 0.135. All right. Is everybody okay with that addition rule? So here's the thing. This only works if our events are mutually exclusive, and sometimes they're not. So I might say, I'm going to randomly select a student out of this class. What's the probability that that student is male or a senior? Are those two completely separate groups? You're either a male or you're a senior? No, you could be both, right? So we would be double counting any males that were seniors if I just added up those individual probabilities. So in that case, if there's overlap, okay, think of it like here's the probability of being a male, here's the probability of being a senior. So when I add those two individual probabilities, I have double counted that middle group. So what do I need to do with those people? Subtract them off, because I counted them twice. So if you're looking on your formula sheet, this is the general addition rule, the last bullet on that first page. So this is for any two events. Or means add. So the probability of one or another. You add them up, and then you have to subtract those people you double counted. So subtract off the probability that you are both. And technically, you could always use this rule. If your events are mutually exclusive, then here's your probability of E. Here's your probability of F. What's the probability that you are in both if you have two disjoint sets? 0. So you would be subtracting off the 0 there. So this is just a more general form of that rule we've been using. Okay. So we're going to do a lot of practice. There's only one more formula we have to write down today. The rest of what we're doing is just examples on calculating probabilities. So the next one, I'm going to give you a picture. We're going to roll 2 dice. And so I have every combination that we might get. Okay, so pretend like you can tell apart the 2 dice. Maybe I have a white one and a black one. So I roll them and I could get a 1 on my white one and a 2 on my black one, or a 2 on my white and a 1 on my black one, or whatever. So here is every possible combination. All right, how many are there? 6. So there's 36 combinations here that would work. All right, so I want the probability of E or F. E is the probability that the first one is a 2, and F is the sum is less than or equal to 5. Are those events mutually exclusive, or is it possible to get a 2 and add up to less than 5? Yeah, we can have both. So we have to use our general addition rule. So that's the probability of E plus the probability of F minus the probability of E and F. And I strongly encourage you to start writing out these formulas as we calculate probabilities. If you write out your formula, it's just a matter of plugging numbers in. When you don't write out your formulas, a lot of times you're sitting here struggling trying to figure out what to do. So I think it helps a lot if you know what you're looking for. So E, the first one is a 2. So the first one is a 2, that's everything in this row. How many of those are there? 6 out of, we said there were 36 total combinations.
1/6.
Mm-hmm. Can reduce it. Plus the probability of F. F says the sum is less than or equal to 5. So 1 plus 1 is less than 5. 1 plus 2, 1 plus 3. 1 plus 4 is 5, so that's okay, but could we have a 1 plus 5? No. Could have 2 plus 1, 2 plus 2, 2 plus 3, 3 plus 1, 3 plus 2, and 4 plus 1. So we agree that's all of them? So how many of those are there? So that's a 10 out of the 36. Minus, how many did I double count? 3. These 3 right here got counted in with both groups. So I have to subtract off those 3 out of 36 because I counted them twice. So then we just calculate it. I don't care if you give me fraction or decimal form. So we should get 13 out of 36 or 0.3611. Is that one okay? Are you guys familiar with a deck of cards at all? Do you know like how many suits are in a deck? Or like diamonds, hearts, spades, clubs. How many cards are in a deck? 52. Okay. So, suppose I take a single card from a deck. I want the probability of drawing a king or diamond. Is it possible to be both? Yes. So it's not mutually exclusive, so we have to do the general addition rule. So the probability of king plus probability of diamond minus probability of both. Probability of being a king. How many kings are in the deck? 4 out of the 52 cards. Assuming no jokers here. How many diamonds? 13 out of the 52. How many of those cards are a king of diamonds?
1.
So we get 16 out of 52. 0.307. Still doing okay with these? Let's look at another. Okay, so I'm giving you a table. It's giving us marital status. And we have males and females in this table. So I did not give you the probabilities here. I just gave you the numbers. So if I'm going to find a probability, we always have to divide it by the total, right? So we'll probably have to do some adding up on here. The first thing I'm asking for is the probability of being a male. So we need to do what? Add up all the males. And what would we divide it by?
Total there.
The total of everybody. So I'm gonna add up the females too. So all together, this has a total of 251.3. So my males, we do all the males divided by everyone. Okay, 0.4875. Okay, so B, I want the probability that a resident is widowed. Right, we need to add up the number that are widowed. And we're just dividing by everyone. You get 0.0569. Part C. What's the probability of being widowed or divorced? On this table, am I allowing for people to be both? No, it's your current marital status. What are you right now? So you fit in one of these categories. So this would be mutually exclusive, so all we have to do is add the two together. So the probability of being widowed and the probability of being divorced. You can do them individually. If you want, you could just add all four of those numbers together and divide it by the total. However you want to go about it, you'll get the same thing. D, probability of being male or widowed. Could you be both here? Yes. So the probability of male or widowed. We have to do the general addition rule. So that's probability of being male plus probability of widowed minus probability male and widowed. So the probability of being male, we already found that. 0.4875, or you could even, I guess if I want to be more precise, I'd bring down the fraction because we did round. Probability of being widowed we found in part B, minus the male and widowed. That was 3.1. So we get 0.532. Is that one okay? The last piece that we're talking about today is a complement. So the complement is the opposite of a set. So if I said, okay, I want everybody in here that is a senior. So the complement would be everybody that is not a senior. So you fit in one of the two groups, either you're a senior or you're a non. So to find the complement, we know that the total probability always adds up to 1. And there's different notations that you might see. This textbook tends to use a C up at the top to represent complement. You might also see it as a bar over the top, and that just means the probability of not being in the set. And that's always just 1 minus your probability. So total probability is 1. You have to fit in one of the two. So if I said there is a 10% chance that you are a senior, then what's the probability that you are not a senior? 90%. Just 1 minus that. So if the probability of A is 0.4, the probability of B is 0.5, and the probability of A and B is 0.1. Find the probability of A or B. All right, if you just look at this, it looks really overwhelming. There's a lot of numbers, a lot of variables, and it's kind of confusing to figure out what we're talking about. Focus on what you're being asked to find. So we need the probability of A or B. I gave you 2 formulas for that. Are these mutually exclusive? Why not? It can be both. If they're mutually exclusive, the probability of A and B has to be 0. It's not. So they are not mutually exclusive. That means you would have to use the general addition rule. So the general addition rule is the probability of first plus the probability of the second minus the probability of both. So if we write out our formula, then it's just a matter of plugging things in. What's the probability of A? What's the probability of B? Minus, what's the probability of both? So the probability of A or B, which are not to be 0.8. Is that one okay? So B, I'm using all the same variables. I have probability of A, probability of B, A or B, A and B. So we're using the same formula. Plug in what we have. What is the probability of A or B? So new question here, so not relying on our answer from the previous one. So in part B, probability of A or B is just 0.7. The probability of A this time is still 0.4. Probability of B is still 0.5. And so you have to solve for this. So could you guys solve that equation? We get 0.7 equals 0.9 minus probability of A and B. Subtract over my 0.9. Divide by -1, so the probability of A and B is 0.2. Can you tell me in this problem, based on scenario in part B, what would be the probability of not A? Not A would be 0.6. The probability of not B, 0.5. You just do 1 minus each of those. Okay, you guys try the last one. A or B is 0.9. Probability of A is 0.4. Probability of B, we don't know. Minus probability of A and B is 0.1. So 0.4 minus 0.1 is 0.3. Subtract that over so you get 0.6 for the probability of B. Alright, so do you guys understand how to just use these formulas to solve for something? So I want to give you the rest of the time to work. Just like yesterday, a lot of these say find and interpret. You do not have to do the interpreting piece.